After dedicating a fair amount of time on configuring and installing Windows Server 2016, it's time for us to move to the next chapter, which is networking in Windows Server 2016. Hello friends, this is Nick from NLB Solutions, and before we continue with the first topic of the networking with Windows Server 2016, I just want to thank everybody who has subscribed to NLB Solutions. Today we have reached 5,000 subscribers, which is a huge milestone for the channel and for me, a huge achievement, and I just want to thank everybody who is following us and subscribing to the channel and liking the videos. Thank you very much, guys. So before we start working with networking in Windows Server 2016, we need to lay down some basics. And IPv4 is a great example of a basic that every administrator needs to be familiar in order to configure network connectivity between the devices in the organization and outside the organization. So I made a small presentation describing the IPv4, and then we can switch to my virtual machines where we can configure this in practice. So IPv4 abbreviation stands for Internet Protocol version 4, and it's basically an IP address that is defined in a 32-bit format. The first example is the bit representation of an IP address, and the second example is a representation of the same address but in decimal values. And we use decimal values to make things better to understand. Every administrator works with thousands and hundreds and thousands of IP addresses every day. So if we need to remember the bit representation of every IP address, it's going to be a nightmare. So basically, every IP address contains 4 octets, which you can see right here, of zeros and ones, and these are the bits that are off for 0 and on for 1. And the first representation, the bit format, you can see we have some ones that are enabled, and they represent the decimal value of 172 for the first octet, then 16 because only one is enabled on a specific location. Right on the bottom, I've tried to show you how this is being defined. So you can see that in here the first bit is enabled, which stands for 128. The second one is disabled. The third one is enabled, which stands for 32. Then the fourth one disabled, the fifth and the sixth enabled, the seventh and the eighth disabled. So if we summarize 128 plus 32 plus 8 plus 4, it equals 172. And this is how normal bit format addresses are represented by decimal values. So on the next slide, I've tried to summarize the subnet mask, or what is subnet masking. The subnet mask is being used to define which portion of the IP address is for the host and which portion is for the network. And we know that we have 3 classes of subnet masks: Class A, Class B, and Class C. These address classes were defined and created by the Internet Assigned Numbers Authority, or IANA, and you can see that they are represented, the bits that are enabled are represented by a network prefix right on the back of the table. And most of you administrators who are working with IP addresses are familiar with this one, and what basically you will see is an IP address with a slash and a number, which represents how many bits of the IP address are dedicated for the network and for the host. And on the bottom table, I've created a representation of how many number of networks you can see in a class A, B, and C network. So if we take class C, for example, you can see that the first octet starts from 192 up to 233. And the default subnet mask, you can see that in the first 3 octets, all the bits are enabled, right in here. And this gives us more than 2 million number of networks and around 254 number of hosts per network. So these networks are going to be separate, and you can assign up to 254 addresses to your hosts. And this is the most common class network that is being used by organizations. So if your organization is less and it needs less than 254 addresses, you can use class C, for example. So on the next slide, I want to speak about public, private, and APIPA addresses. So what are the public addresses in general? They are facing the internet and are routable addresses and must be unique. And this is an example of a public IP address which is routable on the internet and can be accessed around the world. On the other hand, private addresses are not routable on the internet, and you can see that there are 3 networks that are set to be private networks. And in my demonstrations, in my environment, you will see that I'm using the 10.0.0.0/8, or in my case /24, because I don't have that much hosts to use. So as they are not routable on the internet, they need to use a technology to be routed outside of the internal network, and this technology is network address translation. So if you want to know more about network address translation, there are a lot of documentations around the internet and you can get familiar with. And as you see, they are assigned internally in organizations so that they can provide internal access to machines between each other, and on the other hand, they can save public IP addresses. So in an organization, you can have only one public address, but internally, using NAT technology, you can have multiple internal networks with high amount of IP addresses being assigned to devices. So a good example of a private IP address is 192.168.0.15. So what is a APIPA address? APIPA stands for Automatic Private IP Addressing, and typically when a computer is running on Windows or any other operating system, it needs an IP address to start communicating with other devices on the network. So if you haven't assigned a static IP address and your DHCP, or you don't have a DHCP server within your network, your computer will be assigned with such a APIPA address. And the range used for a APIPA starts from 169.254.0.1 and ends to 169.254.255.254. So basically, this address is not routable on the internet, and your machine is not going to be able to communicate with other machines within your network, except from other machines with APIPA addresses. So what is the default gateway? In short, a default gateway is a device, usually a router, that forwards IP packets to other networks. So every organization has multiple routers, for example firewalls, even firewalls, that route information from the organization outside to the open world or the internet. Routers can be also used to route information from one subnet to another subnet within the same organization. So if you want your devices to be able to go outside of the network that you've configured for them, you will need to have a default gateway. If you don't have a default gateway, the devices will be able to communicate, but only in the network they are in. Before I move forward with configuring the actual IPv4 settings on a server, I just want to say a few words about subnetting. And subnetting is a topic that most administrators are not really happy to work with, but when you know the actual concept, it's really easy and friendly. What subnetting means actually is it provides the ability to divide large networks into multiple smaller networks. So for example, if we have a class A network, which a single network provides more than 16 million addresses, you can divide this network using subnetting to provide less addresses to the users. So for example, if a single internet service provider gets one class A network, it receives a huge chunk of the available IP addresses from the IPv4 pool. Because you notice from the first two slides, the IPv4 has a huge limitation of only 32 bits in the address, so it provides a limited amount of addresses in total. And if you are familiar with IP addressing, you may have heard about the IP version 6, which instead of decimal uses hexadecimal, and it contains a lot more IP addresses. So moving forward in the future, we'll start using IP version 6, but for now we are still stuck with IP version 4. In the table in front of you, I've made a small cheat sheet where you can see that increasing the number of bits that are dedicated for the network decreases the number of available IP addresses for the hosts. So for example, if we start from bottom to top, we have the network prefix of a 16, and the number of networks available is only one that provides more than 65,000 addresses. And on the top, you can see that if we subnet this network to a network prefix of 30, we'll have more than 16,000 available networks and only 2 available IP addresses. On the right side of the table is the subnet mask that we can use to assign with that IP address so that the two hosts, for example, can communicate between each other. What I can suggest is you can go online and find subnetting calculators, and there are a lot of websites that are offering this feature, and you can use them to verify your own calculations with subnetting. And if you want, of course, you can use them to calculate what is the number of devices, number of hosts that you need to assign IP addresses, and use the calculator to do the math for you. So go ahead, search online for subnet calculators and play with them so you can get familiar with the terminology of subnetting. After you have some theoretical knowledge of what is IP version 4 and what is being used for, what we can do now is I'm going to show you how you can configure this in practice. So using the server manager, going to local server, and then going to Ethernet 0, if you open this, you'll see that the network connections appears. So in here, this is basically the GUI interface where you can change the IP address of the server. So if you go to Properties, and then select the IP version 4 or Internet Protocol version 4, and then Properties, you will see a small tab where you have the IP address, subnet mask, default gateway, and DNS servers. So you can see in my network I have the IP address of 10.0.0.2 and the subnet mask of 255.255.255.0. So what this tells me is that the first 3 octets are dedicated for my network, and the last octet is dedicated for the hosts. So if you remember correctly, this gives me 254 available addresses. The default gateway is usually assigned the last address from the network or the first address. In my environment, I decided to give the first address to my domain controller and the last address for my default gateway. You can see you have preferred DNS server and alternate DNS server. So all the requests will be sent to my primary domain controller for DNS resolution, where I have the DNS application available. This scenario describes the static private addresses. If you click on the radio button Obtain an IP address automatically, you will see that all the settings are being dimmed out, and my server will be going to start looking for a DHCP server within the network, and it's going to ask for an address to be assigned to it. The same I can do with the DNS servers. So it's going to look both for IP address and DNS server settings. You can see that another tab has appeared, the alternate configuration. And in here, if I click, you can see that it's staying on automatic private IP address. And this is the APIPA address that I've spoke about. So if my server is not able to reach the DHCP, it's going to assign a APIPA address to it, and it's not going to be able to communicate within my network. So this configuration, for example, can be changed, and you can configure some static IP addresses in here, but in the server scenarios it's not widely used. The alternate configuration is pretty much used for desktop operating systems, or when people are using laptops both in home or in the office. So for example, in home, let me just assign a APIPA address. So in home, for example, they can obtain an IP address automatically, but in your office, you do not have a DHCP that is giving IP addresses to your desktops, which in some occasions can be true. In this case, you can assign a alternate configuration in here, and when the computer is not able to pick an IP address, it will use this alternate configuration. So I'm going to cancel this one because I want my server to have its address at the moment. And we can switch to the command line tools that are being used to configure the address. For this purpose, I'm going to open a command line window, because the first thing I want to show you is how you can configure this with CMD or command prompt. The command that is being used for configuring a network address with command prompt is called netsh. And then we are going to specify an interface, IPv4, and then we are going to set address name to the name of my network interface. And my network interface, you can see it right on the left side, it's called Ethernet 0. Okay, and the source is going to be static for static IP address, and the address itself is going to be 10.0.0.222. So let's change the address to 10.0.0.222, and we need to assign a subnet mask, and this is going to be 255.255.255.0, and we need a gateway as well. So the gateway is going to be 10.0.0.254. So if I press enter to this one, I'm going to change the IP address from 10.0.0.2 to 222. So let's see. So after changing the IP address with netsh, you can see straight away on the top the address changed, but I'm going to just verify this. And properties, and then IPv4. You can see that the IP address has changed from the number 2 to 222. So for the next thing, I want to remove the DNS server. So I'm going to close and then just verify that I've removed it. and you can see that the preferred DNS server is missing. So I'm going to then set the DNS server using netsh, and then interface, set DNS, and name, again, the name of the Ethernet address of the network card, which is Ethernet 0, and then the source is going to be static, and the address, I'm going to return it to the way it was, which is going to be 1. Let me just see, the following command was not found. Let me just see. netsh interface set DNS name. Oh, I'm sorry. I set it the wrong way, so I missed the IPv4. Okay? It's saying that the configured DNS server is incorrect or does not exist, but let me just verify the settings of the Ethernet card and click Properties. You can see that my preferred DNS server is set to 001. Not sure why this message appeared, but it seems that it's working. And this is how you can configure the network configuration settings using command prompt and network or netsh command. So in order for me to present to you the next demonstration using PowerShell, what I did is I've configured my network card to pick up an IP address automatically. And you can see that if I refresh, the IPv4 address is assigned by DHCP. So I'm going to straight away open PowerShell and open as administrator. And I'm going to be using the command new net IP address. With this command, I'm going to assign a static IP address to my network interface. And the switch is interface alias. And the alias is Ethernet 0. And then IP address to specify the IP address. So I'm going to assign the old IP address to this server. The prefix length represents the subnet mask, which is 24-bit, and the default gateway is 10.0.0.254. So if I assign this one, you can see that the IP address has changed to 10.0.0.2, and there is some information about the address itself. So let me just refresh my BG info. Okay, and right away the IP address changed on the top to 2. Let me verify this by opening the IP protocol version 4, and the IP address is back to the way it was, to the original one. But I don't have any DNS server addresses. So again, I'm going to use PowerShell to assign a DNS addresses with the command set DNS client server address. And again, I need to specify the interface alias. Okay, and this is going to be for my Ethernet 0, and the server addresses sorry about this one, I'm going to specify only my domain controller. So when I press enter, no output, but when I open again the properties and verify the address, there it is. My preferred DNS server is set to a static ending on 1, like we configured it. Before I end the video, I just want to provide you with few command line and PowerShell tools that you can use for troubleshooting any problems with IPv4. And the first command and the first set of tools I'm going to show you are in command line. So ipconfig is a great tool that can show you your Ethernet adapters and a bit of information about every Ethernet adapter. This is a great tool that you need to for initial troubleshooting of any problems with your connectivity. So I suggest for you to check it. The next command is a fairly easy one, and it's called ping, and this troubleshoots any connectivity problems from one computer to another. So if you specify ping and an IP address, it's going to send packages to a specific destination, and if the destination is reachable, those packages will be returned and you will see the output. But for example, if I try to ping google.com, and I know that I don't have internet connectivity at the moment, so if I try to ping it first, I don't have proper DNS resolution, so let me just see if I try to ping an external IP address instead. So let me just cancel this one and ping an IP address on the web, which is a Google DNS server. You will see that I don't have internet connectivity, and it's going to say that the destination host is unreachable. The other command that I want to show you is called traceroute, and the command itself is tracert, and you can trace, for example, I'm going to trace my domain controller. It's going to provide you a hop by hop information of where the is the route going through, and from where this computer is going to go through to connect to the destination. You can see that tracing the route to DC01 is going to say that it's on the same network and does not need to go to any specific hops to connect to it. But if you use the traceroute command to go, for example, to google.com, it will show you a lot of information, a lot of hops with information how and what is the latency to every destination. Another useful command is netstat, and this will show you all the ports that are being connected to your system at the moment, the local addresses and the foreign addresses. So you can use this one to determine, for example, you can see that I have an RDP session from my computer to this one, and you can see that it's on the local address. It provides the information about the IP and the port that is being used. So you can use this command to provide you a lot of information about any ports that are currently listening on this server, and determine, for example, if you have an application that needs to listen on a specific port and it's not present here, you can then start troubleshooting and find out why it's not present. On the other hand, using PowerShell, we can get the same results even better. So for example, I'm going to show you a few commands, and the first one is get net IP address. So if I use this one, it will provide pretty much the same information and even more about the network interfaces and how are they connected. So you can see that the Ethernet 0 interface is currently assigned with the static IP address that we've configured previously. We have the loopback address, which is a address for every single machine on the network. So if you ping this loopback address, it should return reply. If it's not, there could be a problem with the IP configuration stack, for example. The other command that I want to show you is get net IP interface, and press enter, and you can see that there is some information about the IP version 6 and IP version 4 addresses, even information about the the traffic that is going through these network cards, so you can use this one to check and confirm if your network interface is present or not, if it's recognized. And another command that is similar to ping, the ping command, is called test connection. And if you specify the address for my domain controller in this example, it will pretty much go ahead and ping this IP address, and it will provide me the information afterwards. So let me just see. And you can see that it's continuously pinging my domain controller from the source server to this destination, and these are the bytes of information that are being sent, and this is the time in milliseconds that the server on the other side responds. So if I use Control and C, let me just click here and Control and C, I'm not going to be able to cancel this one, but yeah, it stopped in the end. So these are a few commands that you can use both in command line and in PowerShell to determine if there are any connectivity problems and to rectify them if you find something. And in general, this is IP version 4 in Windows Server 2016. This is the new chapter where we are going to dig deep into the networking of the new server, the 2016 version. This was Nick from NLB Solutions, and don't forget to like, share and subscribe the videos. If you have any questions or queries, you can always put them in the comment section below, and I will try to answer them as soon as possible. Thank you very much for viewing, and see you soon.